Everyone, welcome to Chapter 11, Section 4. Here I'm going to go over areas of polygons, of regular polygons, I should say, and areas of composite figures. So I'm going to start first with going over some properties of regular polygons. We're using a new term called the apothem. The apothem is this line FP. It's similar to the radius. It looks like it, but looking at the red line right there, AP, that's the radius. Remember, a radius goes from the edge of a circle to the center. And so if you inscribe a polygon inside of a circle, you'll have a radius that goes from basically the corner or the vertex of said polygon to the center. But the apothem is always going to come from the middle of the side. And so it's going to be a little bit shorter than the radius, okay? So the next thing to go over is the central angle. And in the next video, I'm going to make 2 videos over this section. I'm going to talk a lot more about central angles. But for right now, you just need to know this. The measure of each angle of a regular polygon is 360 divided by n. Okay? What that's saying is, if I needed to figure out the missing side length of like the apothem or this radius or maybe FB, if I know the central angle, then if you recall from chapter 8, you can do some trigonometry, your sine, cosine, tangent to figure stuff out. But let's just get started. The center of this is K, and the radii are going to go to the corners, so KG and KH. Okay? And next is the apothem. The apothem is KL. Okay? And your central angle is going to be this. This is your central angle. Okay? Go from like radius to radius. So it's going to be GKH. Alright, next I'm going to go over the measure of the central angle. So the little formula was 360 divided by n being the number of sides. I see this is a square, so it's 4 sides. So I just need to write 360 divided by 4, and my central angle there is 90 degrees, okay? And that's basically all the properties of regular polygons. The next thing to go over is the formula for the area of a regular polygon, and that's area is 1/2 times the apothem, that's the little a, times the P, a capital P, you'll see right here, is the perimeter. You're going to do the perimeter of said polygon, alright? So, if you want a little version of how to do the perimeter, of course, you know it's just the sum of all the sides, or a quicker way of doing it is just count the number of sides n, and times it by the number, and times it by the actual side length. So here I have 15, and I'm not in love with this picture because it looks like 15 is the apothem, but you see that the arrow of 18.1 is pointing to the apothem, so 15 is one of these side lengths down there. So the first thing I'm going to go over is my perimeter. My perimeter is, let's see, I have a side of 15 and I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So I'm going to go 8 times 15 for my perimeter, and 8 times 15 is 120. Alright, and now for my area, I just go 1/2 times the apothem of 18.1 times my perimeter of 120. Type that in and you get your area as 1,086 square inches. Alright, let's move on to the next example. Here I have 1, 2, 3, 4, 5, 6 sides. So my perimeter is going to be 6 times 3, which is 18. And so my area is 1/2 of the apothem, 1.7 times 18. Type that into your calculator, and I get an area of 15.3 square feet. All right. The next thing I'm going to go over is the area of composite figures. So I have some figures that are shaded in and I have some that are not shaded in. If it's all shaded, basically you find the area of every shape that's shaded in and you just add it all together. If it's not shaded, then you find the area of like the macro shapes, I guess like the big shape, like this rectangle, and then I'll subtract out the area of the triangle, as there's an empty triangle inside that rectangle. So since I'm on it, let's just do this one first. My area of my rectangle is 6 times 5. Base times height, length times width, whatever you want to say. So 6 times 5 is 30 meters squared. All right. And that's my area of my rectangle. Okay, the next thing I need to figure out is my area of the triangle. So let's see here. If I were to redraw this triangle, I have 4 here, 4 there, and then I know this is going to be 6. The area of a triangle is 1/2 base times height. I don't know my height. I need to figure this out. So if I draw a straight line down there, I've made a right triangle. And that means I've cut this in half. So I have a 3 at the bottom and a 4 as the hypotenuse, and I don't know the height. All right, so Pythagorean theorem. You know the hypotenuse, so that's 4 squared. So you're going to subtract 3 squared. And you can type that into your calculator, but I know that 4 squared minus 3 squared, I know that's 16 minus 9. So I know that's going to be, I know my missing height, it's the square root of 7. So I'm going to write square root of 7 right there. So my area of my triangle is 1/2 times your base of 6. 6 was the base of the whole triangle, not 3. 3 is the base of like the half triangle. Times my height of the square root of 7. So type that in and I get an area of about 7.94. Okay. Next, I need to look at, well, I had the area of the rectangle, the area of the triangle. The triangle is unshaded, so just subtract. So my shaded area is going to be 30 minus 7.94. Type that into your calculator, you get a shaded area of 22.06 meters squared. All right, so that's what you do if it's unshaded. Now let's do 2 examples where everything is shaded. Here I have 3 shapes. I have a triangle on the side, I have a trapezoid in the middle, and then I have a half circle at the top. So let's start with that half circle. So I'm going to need to find the area of a whole circle and just cut it in half. So area of a circle is pi r squared. And 2 is that whole length of the top, so the radius is half of that. So pi times 1 squared. And then remember, this is a semicircle or a half circle, so you got to divide that by 2. So type in pi 1 squared over 2, and that's going to be 1.57 square feet. Next, I need to find my area of, I guess, my trapezoid. And that formula is going to be 1/2 times my base, times my height, excuse me. So let's see, what's the height of this trapezoid? It's 7. So 1/2 times 7 times my base 1 plus my base 2, which is 4 plus 2. So 1/2 times 7 times 4 plus 2. Type that in, and that's an area of 21 square feet. And then the third thing I need to do is I need to get the area of that triangle off on the side. So area of a triangle is 1/2 base. Looks like I have a base of 3.25 and a height of 7.75. All right, this is a parenthesis. So type that in. Looks like my area of my triangle is 12.59 square feet. So now I just need to add these three areas up. Add up 12.59, 21, 1.57, and my total area is going to be 35.16. All right, and then don't forget your unit. That was square feet. And there we go. The last one to go over is I have this rectangle. I have a circle cut in half but put it both in, so I have one circle. And then I have a triangle off to the side. So I'm going to start with that area of that rectangle, which is, it was 32 times 16. So my area of my rectangle, 32 times 16 is 512 square feet. And the next thing, let's cover the area of that circle. So my circle, you see, it had a diameter of 16, so that means it's going to have a radius of 8. Okay, so let's plug 8 in to your pi r squared formula for area of a circle. I type that in and I get an approximate area of 201.06 square feet. That's a 6. All right, and then the last thing to cover is the area of that triangle. So let's see here, I have a base of 15 and then I have a height of 32. It's the same thing down there. So I'm just gonna go 1/2 of 32 times 15. And that's gonna equal 240. So now just add everything up since it's all shaded in. Add that all up, and we're going to get a final answer here of 953.06 square feet. Don't forget your units. And that's it. That wraps up the notes. Okay? Stay tuned for a bonus edition, I guess, of 11.4, more regular Polygon area examples. Goodbye, everyone.